Let's continue with the unit 2. It is very important, the properties which we are going to discuss in this video. These are very important with respect to assessment, exam, as well as with respect to field and also for the upcoming experiments which we are going to do inshallah in the lab. So please focus and stand tuned. The first one is there are several properties, so we will discuss it one by one. The first one is void ratio, porosity, degree of saturation, water content, unit weight, and specific gravity. So we are going to discuss this all one by one. So let's start from void ratio. What is mean by void ratio? So you can read the paragraph by yourself. I will give you here the concepts. Void ratio, it is denoted, its symbol is E. Okay, it is denoted by E. So it is the ratio of what? Volume of words to the volume of solids. Volume of words is equal to how much, as we discussed in the previous video? Volume of air plus volume of water. Because in the voids, maybe air or maybe water is present. So this is volume of voids divided by volume of solids. Like this, you can see this is volume of water and air, and this is volume of solid. So what does it mean? This is the soil sample. These are the solid particle, the circle one. Okay. So now there is the gaps between them, voids. So some of the void is filled with water, and some of the fluid is, and some of the voids air is present. So now E is equal to how much? VV divided by VS. As we know, if the volume of void is more, what does it mean? If there are more voids, like see this one, more voids between the particle, so what's happened, the void ratio is more. So if the void ratio is more, so it's mean the soil is loose, it has less bearing capacity, or it has the ability to take less load, because it is, when the load is coming on it, so then what, the hawa will move out, the air will move out, so it is compressed. So it's mean if the voids is more, the material is loose. So we can find out the type of material through this. No, if E is equal to V divided by S, if the voids is, sorry, if the voids is less, so it's mean the void ratio is less. It is directly relation as we discussed in the previous video. So if the void ratio is less, so it's mean the voids between the particle, it is less. So when the gap between the particle is less, so it's means solid is more. So when solid is more, so it's mean the strength of soil is more. One another thing, A is equal to VV divided by VS. This void ratio is the ratio of same parameter, volume, both are volumes. What is the unit of volume? Meter cube. What is the unit of volume? It is meter cube. So both are cancelled with each other. So E is no VTO, so it can be calculated in percentage some of the time. I think you got it. So now we'll go towards the next one. What is the second one is porosity. Again, the porosity, it is denoted by N. Porosity, sorry, it is the volume of voids with respect to total volume. So what is volume of voids? Volume of air plus volume of water. Volume of water. What is total volume? It is volume of air plus volume of water plus volume of solid. So what does it mean? This is a soil particle. Okay. So in this soil, how much sorry voids is present to the total volume? This is called what? Porosity. So porosity, again, it is the ratio between both our volume, VV and VT, both are volume. So meter cube divided by meter cube, it has no units, it is dimensional less. The third one is degree of saturation. What does mean by degree of saturation? The degree of saturation is denoted by S. So it is volume of water with respect to volume of voids. What does it mean? In this picture, it is very clear. How much water, how much water is present in the voids. These are the voids. In these voids, how much water is present? If the all the voids is filled with water, 100% the void it is filled with water, so it is called what? Fully saturated. If all these voids gaps it is there is no water, all of them are filled with air, so it is called what? Dry soil. If some of them are filled with water, some of them will fill with air. So here the value of S is equal to how much? It should be how much? It is 0 because there is no water. Here is how much? S is equal to 100. If there is water and hawa both are mawjood, so S is equal to how much? It should be between 0 and 100%. So it may be 1, 2, 3 up to 99. So in simple, what is degree of saturation? Degree of saturation means how much water is present in the total voids. How much water is present in total voids of soil. The fourth one is water content or moisture content. Moisture means again what it is concerned with the water. So there are three things: saturated, moisture. So when you heard these two words, so it is connected with the words water. So you directly think that when you heard the words saturated and moisture, so you should to think that it is something about the water. What is water content? The water content represents the amount of water present in soil sample relative to the weight of dry soil. It's indicate the soil moisture condition at once. So inshallah, we will do this in the it is our first practical experiment. What does it mean? For example, these are the soil we check from the site, okay, and its weight is W1. We put it this in the oven for how much time? At 110 plus minus 5 degrees centigrade for how much time? For 24 hours. After that, we collect the sample again. If the sample again, so now as we know, in there is some moisture or water, it is present in the soil. So when for the 24 hour, it is subjected to a very high temperature of 110 degrees centigrade. So all the water which is present here, so it will become what? Evaporate. Bukhar. Bukharat, it will evaporate. So no, in this sample, there is no water. So it is purely what? Solid and air. So this is W2. So W1 minus W2. So it will give what weight of soil in solid form. So in simple, you can say this as well that unit weight or water content is what it is the weight of water with respect to weight of solid multiplied by 100. How much water is present in the soil with respect to the weight of solid in the soil sample, then multiply by 100. So it is your what? Water content, and it is denoted by W. The fifth one is unit weight. This we already discussed in the very first. That unit weight it is represented by gamma. Gamma it is what? Weight divided by volume. So this is what weight of divided by volume. Weight of soil divided by volume of soil. So what is the weight? Weight may be weight of air plus weight of water plus weight of solid divided by volume of air plus volume of solid plus volume of, so we make it volume of water plus volume of solid. So as we know, Hawa is no weight, so it is 0. So Ws plus W, as we know that air is no weight, so it is become how much? WW plus Ws divide by volume of air, volume of water plus volume of solid. So this is what unit weight, this we already discussed in the previous one. So now as you can say, if the amount of water, this is the soil sample. This are you can see here is the gap. So here the white it is air, the green or the blue it's represent water, and the gray colors is represent the solid. So if in the voids the water is present more, so it's mean, like, what is the formula? Weight divided by volume. So where is the weight more? Here, because here is no weight and water is weight. So if the water is more present in the gaps or in the voids between the soil particle, so it's mean its unit weight is more. As the amount of water is decreased, and we already know that Hawa is no weight. So if the amount of water is decreased, so its unit weight is decreased. Here you can say the water content between the particle, which is called voids, is less. So here the density is less. So it's mean if the waters between the particle is more, so it's mean the unit weight is more. If the water present between the particle is less, so its unit weight is less. Why? Because as we know, unit weight is what? Weight per unit volume. So if the total weight is more, so the unit weight is more. Total weight is less, unit weight is less. Here is another term which is called what? Bulk unit weight. Bulk means total in large. Sorry, so it is the unit weight, same like unit weight simply. Bulk unit weight, so it is denoted by T. So it is weight, total weight divided by total volume. So what is total weight? Weight of water plus weight of solid, and we already know air is no weight. So what is total volume? Volume of air, volume of water plus volume of solid. So this is called what? The bulk unit weight or simple unit weight. The third one is dry unit weight. It is very clear from its name. The unit weight, the formula is same, W divided by V. So here what is the weight? No water. Weight of air plus weight of water plus weight of solid divided by volume of air plus volume of water plus volume of solid. So as we already know, air is no weight, so it is zero. In dry, unit weight means what? Dry. So there is no water. So here the weight of water is zero. So only Ws is remain. So it is how much? Ws divided by total. This is the total volume. Total volume. So it is called what? Dry unit weight. So if it is come in the exam, what is the formula for dry unit weight? So it is weight of solids divided by total volume. Sorry. Specific gravity, as we discussed previously as well. So specific gravity, it is the unit weight of any material or any substance with respect to unit weight of water at 4 degrees centigrade. Same density, you can say density of any material divided by density of water at 4 degrees centigrade. So here the water, it is our reference substance. Reference substances means we can compare the other materials with respect to water. For example, here you can see what is the unit weight, the specific gravity of sand, it is 2.60. So it's mean the sand, it is 2.60 times, it is heavier than the water. For example, there is cotton, and we know the density of cotton is less than the water, so maybe it's come 0.5. So it's come the specific gravity of sand, if it is come 0.5, so we can say cotton is 0.5 times less weather or lesser than water. So here water is our reference, or you can say the datum or benchmark to which we can evaluate or measure other substances. Either the other substance, it is heavier than the water or it is lighter than the water. So we can use lesser or lighter words. Okay, the last topic is relative density. It is denoted by d, or relative density. So the term derived velocity is the parameter that compares, in which we compares to volume reduction achieved from compaction in situ. In situ means on site, to the maximum possible volume reduction. How much, for example, this is the soil particle. If I applied a load on it through any mean of, so how much we can reduce its strength if the volume is reduced that much, so the soil are very compacted. So how much we can compact, or how can we which removes the air or water from the soil. So it is the it is the parameter in which we compare the loose material which we can take from the site in the loose form to the maximum possible volume reduction. This is a soil sample. I took it from the site. So it is in loose form because you can see there is a large gaps between the particle. So I moved it in the lab and compacted it through any mean of compaction. So no, the Hawa, sorry, let me clarify here. This is soil from the site. It is in loose form. So when I bring it to the lab or workshop of soil mechanics, so I compacted the same soil. So no, when I compacted the Hawa, see here there is Hawa here and water present. So the air it is removed by compaction. Compaction's load applied through enemy. So now you can see first its volume is like this V. So then it's become V prime, or it is changed from the big to large. For example, it is 10 centimeter. Now it is reduced to 7 centimeter by mean of compaction. So it is the comparison between the soil from the site and how much we can reduce or compact the soil. So the soils, the value of dr may varies from minimum 0. 0 means it is very loose because what is density is very loose. Which has more, it is very less density. Why it is less density? As we know, density is equal to what? Mass per unit volume. So in this you can see the mass is very less. So when the mass is less, the density is less. Here you can see the density of more, the mass is more because the material is compacted, the Hawa is less, so the mass is more. When the mass is more, the density is more. So from where is zero? When zero means what? So there is more gaps between the particle to maximum 100% very dense. Dense means it is very close. The particle are very close to each other. Then there the voids is very less. So it is practically impossible to remove all the voids from the soil, but we can minimize. We can minimize the voids, but practically it is impossible to make it zero, that there is no gap between the particle. For example, this is particle 1 2 3. So we can reduce, see, we can reduce the gaps. So when we zoom it, so still there is what? There is a gap, but we can reduce the gap by mean of communication. So this is the concept behind the relative density. There is one table given here. So in this table, what is mentioned? Relative density and what is the soil behavior or soil description. If the value of dr is come 0 to 15, so it means it is very loose. Its density is very loose. And it is between 185, so 82, 85 to 100, so it's in very days. So as the value is increased, so it's mean the density is, relative density is also increase. So now you can see from this picture, this is what partially saturated soil is here. So you can see there is the voids in the air. So this is the volume, for example, V. So when the rollers is moved over here, so which press or compact the soil. So now you can see the volume, it is reduced to that much size. So this volume is the water, the air which is present here, it is removed. So here you can see the amount of air is, for example, 10 centimeters. So now here the air is removed how much? To 5 centimeter it is reduced. So the 5% air which is present, so it is exposed by mean of compaction, by mean of load. So this is loose, which is on the side. When we checked it on the lab or inside, so it is the compaction. So there is the formula. How can we calculate the relative density? So dr E maximum divided by E maximum by E minimum. So what is E? As we discussed in the previous video, E is what? E is the void. E is void ratio. So wide ratio maximum minus wide ratio divided by wide ratio maximum minus wide ratio minimum. And this is E maximum. How we will calculate E maximum? Calculate is this is porosity maximum divided by 1 minus porosity maximum. E minimum and minimum minus 1 minus n minimum. So we can try to solve one question, it will be clarified. Determine the relative density for a given sandy soil. Sandy soil has maximum porosity and maximum is given to you how much? Again, given data is equal to how much? And maximum 0.45 and minimum porosity is equal to how much? 0.29 and E is equal to wide ratio is equal to 0.69. So we need to calculate dr. So what is the formula for dr? Dr is equal to E maximum minus E minimum, E maximum minus E minimum. So we don't have the value for E maximum and E minimum, but E already we have. So how can we calculate E maximum? E maximum, we already have the formula n maximum divided by 1 minus n maximum. So what is the value of n maximum? N maximum is 0.45. So 0.45 divided by 1 minus 0.45, this value E minimum. So is equal to n minimum divided by 1 minus n minimum. Just put the value from the given data. So it is 41. Put the value in the dr formula because no already calculated E maximum, E minimum, and E already we have. So when you put this all value in the formula, so it will give you 0.3 30%. So it's mean 30% it is loose material, it is not compacted well. So you can see in the previous table. So between 15 to 30, so it is 30 is light between 15 to 30, so it is loose material. So this is the end of the chapter. Sorry, unit 2. Thank you guys.